Just to go over, the last day of class is 4/21. For this class, it's 4/20. Last day of class, all homework will terminate at midnight. After the last day of class, I will go through the weights and percentages on the grade book to make sure they are correct. After the last day of class, I will also assign zeros to any incomplete work. After Tuesday, 4/21. Notice I said that twice. After 4/21. Your last test, I got to look at that right here because let's see what it's called. There it is. I hadn't posted it yet. Your last test will consist of a Unit 4 test. It'll say Unit 4 test. Okay, let me make a note on this because this one says, this looks like Unit 3. It's going to say Unit 4 test. I'll change that. Okay, it'll be right here between Unit 3 test and the final exam. Okay, that's the last two things that you will have to take after 4/21, because your last test will start on 4/21 and end on 4/28, and your final exam will end on 4/28 also. So, does anybody have any questions about the last week class? I think this is the third day I have covered this material. I think I covered it Wednesday and Friday of last week, and today makes the third day that I have covered this material. Y'all tell me if I'm wrong or right. I think I've covered it at least 2 or 3 days. So hopefully I won't have somebody email me with a stupid question. All right, so today we're going to start with, tell me what I think we finished with 8.2, didn't we? So I need to go into 9.1. I think that's, y'all help me out. I think 9.1. Look through your notes. I think we finished 9.2. We finished 8.1. Well, 8.2 is not 8.2 is not a lot. It's only like a few slides. So let's go with 8.2. Now I have covered 8.2 in the 12010. So you might, oh yeah, we missed Monday. That's it. Okay, so I did post a video from last semester on, 8.2. That's, y'all should have watched that, but I'll go ahead and go over it right quick and you can watch that 8.2 video if you need to. Okay, I don't need this one. I don't need this one. All right, so let's go down to 8.2. Now, before I go over 8.2, I want to talk about what we've covered so far. And what we've covered so far, well, by the time we get through with 8.2 today, this is what we've covered. In Chapter 7, we were given a number, and we were told that mu is equal to 10, and the standard deviation is equal to 5, and that told you to draw a curve. And that'd be 0, 1, 2, 3, -1, -2, -3, 0.15, 13.5, 34, oops, that's wrong, That's 13.5. That's 2.15. 34, 34, 13.5, 2.35, and 0.15. And you were told, they ask you, what is the probability that your, let's say this is ages, that a student at the age of 25 will be in the class, or more, or older. 25 or older. Okay, so this is going to be, we'll take the, this will be 15, this will be 20, this will be 25, this will be 30, this will be negative, I'm sorry, this will be 10, 5, and 0. Okay, and they ask you, what is the probability of 25 or older? And you go, okay, 25 or older. 25 or older would be this area right in here. And by the empirical rule, that would be 2.5%. Okay, by the empirical rule, 2.5%. But by z-scores, we would change 25 into, if you have an older calculator, that'd be 25 minus 20 minus 15 over 5, which would be 10 over 5, which is 2. So you would go from 2 to 9999. And could y'all do that on your calculator? Well, I'll do it. So second bars, normal CDF, 2 to 9999. And enter. 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 Oh, Lord. And enter. 2.28%. So your answer is 2.28% or 0.0228. 0228. Okay, now does everybody agree that's what we did in chapter 7? Well, in 8.1 they tell you what if. Now they don't say what if. That's what I tell students. They're asking you, what if you have 10 more students add the class? What is the probability that they would be an age of 25 or older? So what do? Well, the only thing you do now is you still use the same curve. I'm not going to label it again. I'm not going to go through all that again. And I put a 15 here, and a 20, and a 25 here, and a 30, and a negative or 10, a 5, and a 0. But I can't use the same z-score because the z-score is in chapter 7. That's why it's in chapter 7. They're giving us more students. So they give you more students as a random sample of 10 or more students. Then you've got to change your z-score. So now your new z-score, based on your 10 more students, is going to be equal to, or same, what was it, 25? It's going to be 25 minus 15 over, and now by chapter 8.1, we're going to change this to 5 over, and I'm going to put this in red because this is the new stuff, square root of 10. And that is the difference between chapter 7 and chapter 8. So somebody do the math for me right quick if you don't mind. That's going to be 10 over square root of 10 is 3.1. 5 divided by 3, I have no idea. I'm just going to put 5 divided by 3.1-ish. Okay, somebody give me that number. Can y'all give me a number? .32. Everybody get that? 6.32. So that's way up here. 6.32 to 9999. So now do inverse norm from 6.32 to 9999. That's going to be like 0.0001. So that's going to be equal to 0.0001. Anything above 3 should come out to be some variation of 0, pretty much. That's the difference between 7 and 8.1. So I just wanted to review that to make sure you understood what the importance of 8 is. That's 8.1 right there. If you can do this right here, do this problem. This is part A in 8.1. This is part B. So that's before in chapter 7, you just had part A. So hopefully, now 8.2, I'll go into the slides and I'm just going to go ahead and show you, sorry. I'm just going to go through and pick out the formulas because, let's see, is that chapter 8? I guess it is. Yeah. Because you see, that's 31 and the end is 45. So we only got like 14 slides and about 4 of them are worthless. Okay, so just telling you, there's not a lot of information here except for a couple of formulas. P hat. Now instead of, in 8.1, we were dealing with the mean is equal to 15 and the standard deviation is equal to 5. We were given this. And we were asked to find the probability of some event. Capiche? Oops, I'm sorry. Okay, in 8.2, you're not going to be given a mean and a standard deviation. You're going to be given a proportion. And it may be in the form of x over n. It may be in the form of a percentage or a decimal. But it's basically going to be called p hat. Okay? So that's the difference. And they're going to ask you for the probability or the mean or the standard deviation. Okay? And there it is. Write that. You don't have to write down the whole paragraph. Just write down that that's called a point estimate of population proportion. That's important. A point estimate for population proportion is p hat. And it's going to be given to you instead of a mean and standard deviation. And you have to find the probability or the mean or the standard deviation. Okay, so p hat is x over n being your biggest number. And here's an example. And go ahead and write that example down because, you know, that's a test question. And if you'll notice in your homework, there's only like 6 questions on your 8.1 and 8.2 homework. 6 questions. So it's not very difficult. 8.1 and 8.2. If you can find p hat, then of course what's the complement of P hat? Q hat. So make sure you find P hat, Q hat right after you find P hat. So if P hat is 0.2, if P hat is 0.2, then Q hat is 0.8. So make sure you can find P hat and Q hat. Because if you can find P hat and Q hat, then you can find the other things that we need in 8.2, which focuses around the mean and the standard deviation. I hope y'all should, I mean, you don't have to write down word for word this, but just the general, you don't have to write down, just in a poll. In a poll, 1745 or 349 said he handled out of 1745, he handled the economy good. And then P hat is equal to 0.2. Therefore, Q hat is equal to 0.8. That's what you should have on that slide right there. Here, they don't give you a x over n. They give you a what? A percentage, which you can write as a decimal. So in this case, P hat is equal to 0.42. And I'm going to skip these because you don't need to worry about that. Although, I will tell you this, and I think they tell you this here. You need to write this down. And I'll make that a slide so you can see it better. Tell me when you got that written down, those three things. And again, you don't have to write it down for word. Just say shape. As n increases, the shape of the sample curve or the sample portion becomes normal. That's something. As n increases, the shape reaches normality. The center. The mean of the sample distribution of the sample proportion equals the population proportion. Write that down. And then the standard deviation of the sample size the sample decreases as the sample size n increases. The standard deviation decreases as the sample size increases. So you need to write those three down. Let me know when you got them down. Mr. Brooks, how about you?
I've almost got him. Give me one more second. I've got them.
Okay. And this is mainly just for you to know, because they may ask you some Philadelphia lawyer questions, and this is what it pertains to. Okay, here we go. The shape of the sample distribution is approximately normally provided. MPQ is greater than or equal to 10. This is kind of a little test. If your MPQ is less than 10, you can't do the problem. Okay? So always check it, even though most of my problems are going to be doable. NPQ has got to be greater than or equal to 10. Most of the time, all you have to do, if you got an N that's equal to 500 and a P equal to 0.5, well, what's half of 500? 250. So most of the time you can just look at N and P and say, well, and then take half of 100 or 250, that's 125. So most of the time you can do this in your head. The bigger the number, the more you don't have to worry about this. That's what they were saying in the previous slide. And here we go. The mean of the sample distribution of p hat is mu p hat is equal to p. We'll get to that when we get to the example. And this is what you need. The standard deviation of the sampling distribution of p hat is sigma sub p hat is equal to the square root of pq over n. So you've got to remember that npq greater than or equal to 10, and then you got to remember the standard deviation of p hat is equal to the square root of pq over n, and that's what 8.2 is. Okay, so 8.2 you can write on one page how important it is. I mean, that's the three. There's 2 or 3 formulas and 2 or 3 concepts, and that's it. Because you're getting ready for 9 and 10. 9 even gets you ready for 10. Okay, and I hope to get at least to 10.1 by Monday, but I don't know if I'm going to make it or not. Okay, and we talked about, we already did that. Okay, regardless of NP, whether or not the mean of the sample distribution is still that. When sampling from a data size no more than 5% of the population. So N has to be less than or equal to 5% of N. That's not a big deal. Again, what if you have 100? Okay, 5% of 100. Okay, little n has to be less than 5% of 100, or whatever the case. The larger the number, the more you don't have to worry about it. Okay, this is an example. You don't have to write it word for word, but it's a test question. They're going to ask you to find the p hat, which p hat is 0.42. So q hat is 0.58. All right, so you know that from the get-go. You've got sample of 50. So that means in this question, and I'm just going to write down how you would attack this question. First thing you're going to say to yourself is, well, they give me p hat. I don't have to calculate it. P hat is equal to 0.42, and Hubert said always find Q hat. Q hat is equal to 0.58. And they give us N is equal to 50. So the only thing you can do here is NP over N. It's the only thing you can do here. You can check it. Well, what's 10%, or let's see, let's just say 50%. What's 50% of 50? 25, and half of 25 is 12.5. 12.5 is greater than 10. So you can do that in your head. Okay? We know that since p hat is equal to 0.42, we know that the mean for the p hat is equal to 0.42. And that's just in general. And then the standard deviation of p hat is equal to the square root of 0.42 times 0.58 divided by 50, which is equal to 0.0698. And that, my friends, is the kind of questions they will ask you in the homework. All this is given. Now, the only difference given in 8.2, the only difference is they might say 400 people were sick out of 500. What is p hat? So they may write this differently. They may say 42%. If they do 42%, you just change it to a decimal. If they give you 200 people that work at blah, blah, blah got sick out of 500, then you would say 200 over 500 and that would be 2 over 5, which is equal to 0.4. Okay? So you would change it. Your final destination is a decimal. Whether it be given to you as numbers or a percentage, you change both of those, you get both of those into a decimal, then you can find Q hat, and if you're given N, then you know you've got to do those two things right there. And that's pretty much 8.2. But I'll see if there's another. Here again, what is there's my proportion right there. Okay, 90 is well, what's, let's see, that's 20%. What's 10% of 90? Well, that'd be 9. So 20% would be 18. Half of 18 is 9. 9 is going to be less than 10. So they may, let's see what they do there. No, 90, okay. It's not 20%, it's 18. So it is 13. I got 9 because I was doing 20% instead of 18. So, and there you go. Same thing. Now, they did add a second part, and that's where you take 19 minus 18, and you put it over that 0.0412. Because that's your standard deviation. So you need to make a note right here. This is x minus x bar over your standard deviation. Now the reason you didn't do the square root of n or anything like that, the square root of n, that 8.1 stuff, that's a different problem. Okay? This 8.2, you got to find that z-score. You don't use that square root of n. This is a different animal. You do x minus x bar over your standard deviation of p hat. So if you need to write it down like that, you can. So here they give us point p hat is equal to 18.8%. So p hat is equal to 0.188. Therefore, Q hat is equal to I have no idea. That'd be 0.812. 0.812. Check me on that, please. And then N is equal to 90. Okay, this is what they're giving you and I'm going to write this down. This is what they're given to you in this problem. And this is 8.2. Okay, so the first thing you do is you say, well, NPQ has to be greater than or equal to 10, and we saw that it checked. And then we also know that p hat, the mean, is equal to p hat. The mean of p hat is equal to p hat, which is equal to 0.188. And then my standard deviation is equal to the square root of 0.188 times 0.812 over 50 or 90. And we know that's equal to, what did we say it was equal to? 0.0412. 0.0412. And that's your standard deviation of p hat. So now you're going to do your z-score. B, you're going to do your z-score. Z is equal to x minus x bar over standard deviation. Well, in this case, you don't have a standard deviation, so you're going to have to do, the only standard deviation you got is of p hat. So in this case, you would put p hat right there for your formula for 8.2. And that would be x minus x bar, and they gave you 19. They give you that in the question B or A. 19 minus 18.8 or 0.188, 0.19 minus 0.188, whichever one you want to do it, over 0.0412, and that's going to be a z-score of 0.0485. Z is equal to 0.0485, but we don't write z-scores in 4 digits. I can't stand when they do that. 0.05. So we know that our z-score is right here. So we know above, I think they're wanting to know at least. So we know that our area is going to be less than 50% because it's going to be over this. So it's going to be less than 50%. And they get 48%. You would do in your calculator inverse norm. No. You would do normal CDF, and then you would do 0.05 to 9999, and that should give you 0.4801. Sorry. So that's the 2 type questions, the one I did before and this one, and that's pretty much it. So you got to be able to do NPQ greater than or equal to 10. You got to be able to know that the mean of p hat is equal to p hat. You got to be able to take NP divided by N, PQ divided by N, and take the square root. And then that gives you a new standard deviation, which you can put in your standard z-score. Get your new z-score and go from there to infinity, or from negative 9999 to 0.05, depending on if they're asking less than or more than. At least means what? Your lowest number is whatever, and you go above at least 19. Your lowest number is 19, so that means above. Okay? And that's the 2 type questions I would ask you on homework or test. Okay, here's the second part. Okay, suppose a random sample of 90 school children, blah, 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 result 24. Now they're giving you a new p hat. B is a new p hat. Write that down. B equals new p hat. There's 24. There's your new x. Now what do you do in this case? Well, again, it's different. In the previous section, 8.1, the problem would be written different, and that 24 would be your square root of 24 on the bottom of your, that would be done in 8.1. In this case, since it's 8.2, and since the question is written differently, they're going to give you 24, and you got to go back and recalculate p hat, which means you got to recalculate q hat. So q hat would be 0.7333, and plug and chug with your standard deviation right here. This is your new p hat. So 26% or 27% minus 18.8% over your standard deviation is equal to 1.91, and then go from 1.91 to infinity, and that should give you 0.02. So that's 2%, or 3 samples, 3 samples in 100, resulting in 26% more or more. This is unusual because that's less than, what's your nickel rule? Nickel is 5 cents. Is that more or less than 5 cents? 3 cents is less than 5 cents, so that means it is unusual. And that is 8.2. That's what you should have watched the videos on Monday, or you should have watched yesterday's class in 12010. You should have. Notice I said should. All right, now let's look at 9. Okay, I don't know why it's... Okay, why is it doing this? Whatever. Okay, we already talked about this. Y'all know p hat is x over n. But what are they going to ask you? Well, in 9.1, you're going to be introduced to 2 things. You're going to be introduced, well, 3 things. You're going to be introduced to confidence level, confidence interval, the margin of error,
it's currently
and
10:55
n.
a.m. With the current temperature
So,
of 36 degrees
you
Fahrenheit.
go ahead and write these down.
The low is 40 degrees
I don't know
Fahrenheit.
why it's doing
And the
that.
high is 60.
CL is equal to confidence level. CI is equal to confidence interval. Mo is equal to margin of error. And N is equal to your sample set. Press Control plus over and over to make the PowerPoint bigger. Oh, I didn't know that. Thank you. So that's what we're going to be learning in 9.1. 9.1 is usually, confidence level is usually going to be given. Confidence interval is what you calculate. And these 3 you're going to calculate. You're going to be given a formula for this one and a formula for this one, and I'm going to give you a method using a formula. I don't like the way they do confidence interval in this book, so I do it a little bit different. So I just don't understand why it went to this plus. I don't know why it went to this. I don't know. I don't know how it did this. I must have hit something. Yeah, I must have hit something because, okay, there we go. I must have brought that up accidentally. Okay, there we go. Now we cooking with peanut oil. All right, so here is your example. Let's see if there's anything important before that. No. Okay, here's your example. Go ahead and write this down, at least the first part. Okay, the first part is it's going to be used on several problems, and it's going to be using at 1783 and 1123 on these examples. So that's the actual part of the problem that you're going to see over and over and over. Okay, so the point estimate here, why don't they just call it P hat? P hat is equal to 1123 over 1783. So go ahead and do P hat and Q hat. Go ahead and calculate that. And I'm going to do that on here. So P hat is equal to 1123 over 1783. And if y'all could give me a decimal to 2 points, I'd appreciate it. She already did it. 0.63. Thank you, Miss Carver. 0.63. And Q hat is equal to 0.37. Okay, so that's what you should, if you see this problem on a test, chances are they're going to ask you for those 2 things first. Okay, and I'll put my, I wish I could put this, it won't let me.
New
I
Facebook
wish there was
comment.
some way I could put, well, I can, it's just that I don't want to. There we go. Oh, the things I do for y'all. There we go. Still can't see all of it. But anyway, next one. And there's 0.63. Okay, confidence interval. You can write these down you can write them down if it makes sense to you. Most of the time it don't make sense to people, but you can write it down if you want to. Confidence interval is usually given, and it is usually a number that gauges how confident you are in your work, basically, based on the point estimate, based on p hat. The level of confidence, okay, I'm sorry, confidence level that's given. Okay, I thought that was this one. I don't know why they put this one first, because this one is based on the confidence level, so the confidence level should be defined first. The confidence level is how confident you are in your work in the problem. That's pretty much it. Expected proportion of intervals. What do you expect at the end of this problem? That's your confidence level. The confidence level is usually given, or is given in a way that you can look it up on a index card, and I'm going to show you how to do the index card in just a second. I know I'm running out of time, but I'm going to just spend a couple extra minutes trying to get you to that index card. Okay, do y'all have that much written down? The confidence interval is kind of like the spread. You know how we used to add the standard deviation on the right and subtract the standard deviation on the left? We're going to do that same thing with the confidence interval, with p hat being in the middle. And you're going to have a confidence to the right and a confidence to the left, using your margin of error. Y'all got that written down so far?
Yeah, I've got it.
Okay. Miss Carver, you got it? Yes. Okay, so next, I'm trying to get to the important ones. All right, here's where we get into this is what your index card needs to look like when you start this. Let's say that this piece of paper right here is your index card. I'm just going to go ahead and let's say this is your index card, and this is going to help you if you make an index card with these numbers on it. You're going to divide it into columns, about 5 columns. Skinny column on the left, and then regular columns, and you can make an extra couple of columns. It's not a big deal. You can use them for other things. And the first one is going to be called your confidence level, CL. And I'm going to start with 99, and I'm going to put a percent there, and I'm going to go down 98, 97, 96, 95, 94, 93, 92, 91, and 90. Well, Hubert, why don't you go down to 89 or 72? Why do you go to 90? Well, what do you always want to do when you do a job? You always want to do your what? Your best. 89% is not your best. You want to be 90 to 99% confident. And I tell students, you want to be above what? 95%. But since the homework asks different levels because it's just making up more problems, sometimes you may see an 80% confidence level. Most of the time in the real world, you're going to go with 95 to 99. Can you imagine if Dr. Fauci got up to the American public and said, well, I'm 75% sure? What would y'all do? What would you say if you saw Dr. Fauci on a press conference say, Well, I'm 75% sure that our models are going to work. You wouldn't be very confident, okay, as somebody looking at the material. All right, so, and I don't tell me if you don't know who Dr. Fauci is. If you don't know who Dr. Fauci is, just don't tell me, because it just makes me irritated. You know, with all this going on, and somebody goes, "Who's Dr. Fauci?" Anyway, so the next thing is going to be alpha. Alpha is your confidence level from 1. Okay? So that's going to be 0.01, 0.02, 0.03, 0.04, 0.05, ... 0.10. Okay? And then you're going to put alpha over 2. And that's going to be half of 1 cent is 0.005, 0.01, 0.015, 0.02, 0.025, ... 0.05. And then this is your z, so alpha over 2, and we're going to go with the absolute value, because when we're calculating, we just want to use the absolute value. So I want you to use, you're going to use the inverse norm key. Inverse norm. And the inverse norm, I'm going to pull it up right quick. Second bars, inverse norm. And type in 0.0050, 0.0050. And that's going to give me, go down to paste. And that's going to give me, again, negative 2.576. Negative 2.576. You will notice that most of your homework problems, they go to 3 digits. That's why I'm carrying it to 3. Usually I would carry it to 2. Second entry. Next, I'm going to change it to 0.0100. Negative 2.326. I'm sorry, move it over. Second entry. .0150. Negative 2.170. 0.02. Negative 0.2054. Negative 2054. Now remember, absolute value. So I forgot to drop off the, so I'm just going to put a plus here since we're using the absolute value. I know that's not kosher to do that, say plus with absolute value, but we're just worried about the distance. We're not worried about the direction. So, and the last one, second entry, this will be 0.0250. And I'm going to do the last one down at the bottom. Negative 1.96 or 1.96. And I'm going to do this one. And we're going to do 0.0500. 0.0500. 0500. And that'll give me 1.645. and you need to fill this out right here. And we might use these other three, or you can just make 4 columns. I think there's another reason I have another column. But for right now, this will be quick, because if they ask you for a 97% confidence level, you're going to use 2.17. If they ask you for a 90% confidence level, you're going to use 1.645. Okay, so that's why you need this. Now, if you want to do the calculation on your calculator 15,000 times, knock yourself out. But as of right now, we're going to stop right there, and we're going to call it a day, because now, if you want to go on further, watch the 12010 video or watch 9.1 from last semester. It's on your channel, and you can, catch up, but we'll take off from there. That's slide number 7. If you don't mind putting slide number 7 on there, that's where we left off, Miss Carver. I'd appreciate it. And other than that, y'all have a good day, and I will see y'all Friday.